There's the quiz. So on these, all I wanted you to do was answer the question. Pretty straightforward little questions based on the lecture. By the way, did everyone see that I got the lecture up late Monday night, early Tuesday morning? That was one of the things in the suggestion things. You know, faster turnaround time on the YouTube. Okay. Sine of x. Is that correct? Nope. It's negative sign, right? Negative sign. Come on. exp is just exp of x. You could have also written e to the x. That would have been fine. This is 1 over x. You could have also written x to the negative 1. This one's a little bit hard. This one's a little bit... So what is the limit of 1 over x squared as x goes to 0? That would be infinity with a positive. And there's 1 over x. And there is 1 over x squared. So how do we feel about those 1 to 5? Popcorn. Go question 1. Yeah, the poll. There's no fast way to do the poll. I have to do the polls manually. Okay. They eat time trying to start those up. No, it's not you. It's the system. All right. So we seem kind of comfortable with that. F prime of x here. What I'm going to do... D is infinity because it's asking for the limit as x goes to 0 from the left, but it's got a square on the bottom. So now I'm headed toward 1 over... I'm doing this. This is not the derivative. That's a limit. Yeah, I was off and running. I was about to say do the derivative of that too. Nope, that's a limit. All right, so f prime of x here for the second one equals d over dy, d over dx, sorry, of 2 plus 5x squared, which equals 0 plus 10x. Okay, minimal work required is this. You could have done, if you were doing more work, it would be sum rule. It would be sum rule, d over dx, 2 plus d over dx, 5 x squared equals, and then this one would be 0 as a constant. Write those right here, constant. And then this one would be plus, and then this would be the, I'd pull out the 5 times d over dx, x squared equals 5 plus times 2x to the first equals 10x. So you could have gone either one of those roads. The important thing is that you show that you communicate what happens to that 2. Because otherwise you're like, well, what happened to the 2? Did it like minus something here or something? You just have to show what happens to the 2. Okay. Let's see here. So how do we feel about that one, 1 to 5? Okay. All right, so let's compute this one. D over dy of this thing. I'm going to do this. And the first thing I'm going to do is a little algebra. I'm going to just leave it d over dy of y to the 1/2 plus y to the -2. And now I'll apply a little calculus. I'll apply the sum rule and the power rule in one step. And this is going to be 1/2 y to the 1/2 minus 1 plus -2 y to the -2 minus 3. Not minus 3, minus 1. And that's going to be, okay, so now I've broken it up, kind of everything. Now I'm going to do the thing. So this is going to be 1/2. Well, I'll do the little algebra here. So 1/2 y to the -1 over 2 minus, because that's a minus. And then this is 2y to the -3. And I'm going to be very careful with these because they're fractional exponents, right? This one, I just subtracted the 1 in one step. This one, I'm going to be very, very careful. Okay, because I've got these negatives. Because the instinct will be to make this a -1. No, you know, you got to make it more negative. Okay. So how do we feel about that one, 1 to 5? Okay. As long as it's right. So this is not, I'm not doing this because I want to communicate. I should, but that's not why I'm doing this. I'm doing this for me to keep track. If you had gone from here to here, I would have been happy. Okay? You could have skipped this and gone from here to here. I would have been okay with that. I would have wanted this as a separate step. You can't go from here to here. You need something here to say what you're converting this for the power rule. But you could have gone from here to here. For my personal preference, for my personal thing, I mess these up all the time, and I do this for a living, for crying out loud, right? I mess these little fractions up, these things, these exponents all the time. So if it's a fraction, if it's a negative, I always do it. If it's, you know, if you can do it from here to here, more power to you. You're smarter than I am. I'm just always careful with those because they're a little different. All right, so let's do this. dv over du equals d over du of pi sine of u minus 2 to the u. Here I'm actually going to do the sum rule implicitly. It's not required, but this thing has an exponential form, and it's actually going to generate another term in here. And I want to be a little careful about that. So what I'm going to do is I'm going to actually pull this out. Kind of break it up a little bit. Okay, so this becomes baggage. This right here will become cosine. So I've got my baggage there, and then I've got my cosine of u. Minus, now this thing right here generates an ln of 2 times 2 to the u. How do we feel about that one? That one's a little bit harder. It's sum rule, difference rule, either one. It's really a sum rule, right? I could have split it up into a sum rule and then pulled the -1 out as a negative, and it's the same thing. The exact rule that you're using is not very important, and by the time the test rolls around, you'll probably have dropped this. It's a good idea to do it now for sum rule and constant multiple rule and difference rule or whatever. All of those are fine, but you'll probably drop this by the time we get to the test. But I would keep it for the product rule and for power rule and stuff like that. Speaking of that, it's a good question. There's the product rule. Other acceptable answers are f prime of x times g of x plus f of x, g prime of x. That would have been fine. How do we feel about number 3 there? Derivative of the first times the second plus the first times the derivative of the second. I would remember it in that order because the quotient rule goes in that order, but with a minus sign. So, of course, with addition, it doesn't matter. You could have flipped the order and still been correct. I would remember it in this order simply because of the quotient. That'll give you the same order for the quotient rule, which is has a minus with a something underneath. Okay, for the graphing problem, as usual. Okay, so this is, I will do it first with this. So x is going to infinity, f of x is going to -1. -2, 0. Hold off on that one. Right, that says that the slope at -2 okay, so kink jump or something. If x is greater than 1, then f prime of x is less than 0. What does this condition say? This says that the slopes are negative. Or that the function is decreasing. F is continuous. Okay. So I want it to be decreasing for x greater than 1. I want it continuous everywhere. And I wanted a kink at 1. Okay. All right, so infinity -1 is that point there. -2, 0 is that point there. And that's it. So those are all my conditions. So 1 to 5, how do we feel about interpreting the conditions? Just what they're saying, what they're asking of us. All right, well, right here, I need a slope of 1. So I'm going to deal with that first. By the way, your ID, which you're required to have anyway for a test, is an excellent way to have a ruler on you when you do these. Let's see. I need to do this, so I need to do something like this. Let's just have it come down this way. And I need it to be smooth because I need it to be differentiable. All right, so let's check. Did I do it? As f of x goes to -1 as x goes to infinity, yes. F of -2 equals 0, yes. My slope is +1. Is my derivative here +1? Absolutely. All right, 1 over 1 up. Does f prime of -1 not exist? That is true. I'll write little kink here. And while I'm at it, I'll also put a horizontal asymptote here. Come on, you little ruler. Okay, maybe I won't. There it goes. There's a horizontal asymptote there type thing. F prime of 1 does not exist. There's a kink there. If x is greater than 1, f prime of x is less than 0. Absolutely. And f is continuous. Yep.